Hello and welcome to another Monday night Q&A. I'm joined tonight by my colleague Craig Kemp, who's another member of the Technical Helpline team. Evening, Craig, how are you?
Yep, evening Sam, very well, thank you.
How's your Monday been so far?
Yeah, quite busy this morning. Well, this morning started off with emails and then a few phone calls this afternoon. Yeah, quite busy.
Good. So, as with all our live Q&A sessions, I'll just run through a few house rules. We'll start off with our question of the week, which we posted out across social media channels earlier today, and then we'll go through the answer to that question. Then while you're putting in some questions into the chat, we'll go through some of the questions we've had from previous sessions that we didn't get round to answering. So please start right now putting your questions into the chat, remembering that there's no such thing as a stupid question, only stupid answers, and please remember to be respectful to each other whilst you're in the chat, as the whole idea of this evening is that collectively we try and help each other with the aim of improving our collective knowledge and understanding of all things associated with BS 7671 and the world of electrical installation. So, without further ado, we'll have a look at the question of the week that we posted out on social media earlier today. So, this one was associated with Amendment 2, and the question was, for compliance with Amendment 2 of 2022, do I need to provide the additional protection of a 30 milliamp RCD for lighting in a pub garden? And it was a simple yes or no option of answers. So what's our thoughts on that, Craig?
Well, there was a change from 18th edition Amendment 1 going into Amendment 2 with this particular requirement. So in section 714 for outdoor lighting installations, there's a regulation 714.411.3.4 that was always in there, and it listed some applications where we needed RCD protection, those being telephone kiosks, bus shelters, advertising panels and town plants. And the one that they've added in Amendment 2 is gardens, spaces open to the public. So in short, the answer is yes, under Amendment 2 we would need 30 milliamp RCD protection.
Yeah, spot on. So if we just show the viewers, so this is what the new regulation in Amendment 2 looks like, and as Craig said, spot on, they've actually now given us an example list which includes garden spaces. If we just very quickly have a look at what the previous version was, again, as Craig said, very similar, but it just said that it was required in places such as telephone kiosks, bus shelters, advertising. So we've perhaps got a little bit more help and information with the regulation as it's written now, that it makes it a little bit clearer that it does include those locations that have got access to the public. And I think this is one of those changes where there's good recognition of the driver behind it, isn't it, Craig? That there was unfortunately a fatal accident actually in a pub garden associated with a young lad getting a fatal electric shock due to a fault that wasn't being cleared at a light fitting. So this is what yeah. So this is a good example of one of those reasons why regulations sometimes change, and this is an example of that, where they've recognised a potential risk and then introduced enhanced protection to try and guard against that risk. So that's a good example. Okay, so we'll have a look at question 2. So question 2, one that's fairly common on the helpline, but quite an open question. How do I size bonding conductors in a TT earthing system? So what's your thoughts on that, Craig?
It's a good question, to be honest, and there was plenty to answer on it. We'll start off with the regulation. It's 544.1.1. which says except where PME conditions apply. So we can rule out PME straight away. So what's contained within this regulation is for everything other than PME. So obviously that covers the TT aspect of it. And it says a main protected bonding conductor shall have a cross-sectional area not less than half of the cross-sectional area required for the earthing conductor. And I think that required is a very important point. So not necessarily selected, not necessarily what's been installed, but what's required for an earthing conductor. Yeah, they may not be the same thing. Okay. It also has some other information in there that although it's half the size of the required earthing conductor, there is a minimum of 6 mil and a maximum of 25 mil squared. Yeah, so we've got to fall within those windows, but it is the minimum, half the minimum size of the required earthing conductor.
Yeah, and it's a really good point that you make, that it's the required conductor, because quite often people come in and visually note the size of the earthing conductor, but it may have been oversized, you know, just for simplicity. For example, people often will put the same size protective conductor as line conductor, because then they know they're always meeting requirements, but that might actually mean it's oversized. And then when you come to half that size, again, if the earthing conductor is oversized, then your bonding conductor will also be oversized if you use the same rules. So yeah, it's one of those ones where one word makes an awful difference. So it's half the required size, which isn't necessarily always the installed size.
That's right. And you've got to remember that a lot of the requirements around the sizing of the earthing conductor on the TT installation is for physical strength rather than current carrying capacity. There might not be a lot of current in there, but you know, a lot of the time we need the physical strength because it is a conductor that could be susceptible to damage possibly.
Yeah, and I think that's why it says 6 mil regardless of whether it's copper or something else, and that kind of tells you that it's really thinking at that bottom end about physical strength, you know, and not only resistance or conductance. Yeah, and so it's that reg. I think people get familiar in that they're often looking at PME and being thrown to the relevant table, but they forget that reg actually tells us how we size it for everything other than PME, which would include TT. Another common question, can I run 2 circuits in the same SWA multi-core cable? So what's our thoughts on that, Craig?
Well, a multi-core cable, yeah, you can have more than one circuit in there, to be honest, and there is a regulation that calls it 521.7, yeah, that says 2 or more circuits are allowed in the same cable, provided the requirements of section 528 are met. And we know 528 is all about proximity of electrical services, yeah, so that all covers band 1 and band 2. Can you put them in the same cable? Yeah, and we have to, in 528, there's a list of ways that we can achieve putting cables of different bands in the same conductor. You know, they've either got to be all insulated to the same voltage that's present, the highest voltage that's present, sorry, or they've got to be screened, yeah, with a separation of a metallic screen or equivalent between the 2 bands. But yeah, I mean, we can. You might want to consider labelling if they've got 2 separate devices that need to isolate the same cable. That might be a consideration. And there's got to be no detrimental influence between the 2 circuits involved, or more than 2 circuits. It doesn't necessarily have to be 2, it can be 2 or more, depending on the number of cores that you've got.
Yeah, but there, as you say, there's nothing that precludes it, and as you rightly say, there's a reg that specifically says you can have more than one circuit in the same multi-core cable. So it's certainly possible, but there are some other general regs that we need to comply with, but there's nothing straight out of the box that excludes it. Another common one we get, especially when people are looking at EICRs, is there a minimum height in BS 7671 for socket outlets to be installed above kitchen worktops? So is there a definitive distance given in 7671?
This is a good question, because we do get a lot of questions on this, and not just sockets above kitchen worktops, but sockets in general. You know, whether they're new build, whether they're rewires, whether it's a kitchen refit. There's sometimes a lot of confusion over to what height the sockets should be, and if there is a defined height within 7671. We can say there is no defined height within 7671. Yeah, that there is a regulation that covers it, but it doesn't specify a height either off the floor or off a worktop. There's no measurement in millimetres, as a lot of regulations there isn't. What it does say is they've got to be mounted at such a height, whether it's off the floor or off a worktop, so that we can insert a plug and the flex into the outlet without causing any damage to either the plug or the outlet. Yeah, so we haven't got a minimum distance stated, but there's a rationale there. You know, it's got to be a certain height so that we can easily put the plug in and out and we don't cause any damage. I know typically we used to put them in a minimum 100 mil above the worktop. Yeah, it gives you plenty of room then to get the plug in out. They're nice and accessible. But no, there isn't a minimum height in 7671 for any. Well, no, I wouldn't say for any socket. There may be for some sockets, but certainly not in general.
Yeah, no, you're right, and quite often we get the call about the sockets that have actually been installed in the skirting board. So yeah, it's spot on in that it's not just above the worktops. So yeah, it's really a sort of an engineering judgment based on, you know, what's being used. So if, for example, the sockets outlets are being used, then you can gauge fairly easily, you know, is the socket, is the plug or its cable or potentially its connections under stress because of its location. Then clearly there's an issue, but there's no definitive height given in 7671. It is just a case, as you say, that it has to be mounted at a height above the floor or any work surface to minimise the risk of mechanical damage to the socket outlet or the associated plug and its flexible cable. So yeah, it's all to do with is it safe, is it secure, is it going to cause any undue stress on the cable or its connections. And it's one of those ones in our pocket guides that we issue out. We've got a pocket guide for that issue, and it does talk about a recognised minimum of 100 mil as seen as an acceptable distance. Another one that we get asked as well a lot is another question that's come in. Do single insulated protective conductors need to be installed in trunking or conduit? And I think this comes from, there is a regulation, isn't there, that tells us that non-sheathed cables have to be enclosed in conduit or ducting or trunking. So what about single insulated protective conductors, Craig, that don't have a sheath? Do they need to be installed in trunking or conduit?
Well, the same regulation actually gives you the answer, and I think sometimes we're guilty of reading a regulation, seeing a certain portion of it and stopping and not carrying on and reading the rest of it, because that regulation 521.10.1, it does cover both. So it does start off with non-sheathed cables for fixed wiring shall be enclosed in conduit or ducting, but then the second half of it, the second sentence, says this requirement does not apply to a protective conductor that complies with section 543. So there's two bits to that, right? One of us telling us we've got to put it in, however the second half tells us, well, it doesn't apply to protective conductors. So we can have single insulated protective conductor, bonding conductor, supplementary bonding conductor, even a CPC. We can have a single insulated cable performing those functions without it being enclosed within containment. With the CPC, there's other regulations that come into play about where it's run, how it's run, and the physical size of it minimum size if it's in containment, and a different minimum size 4 mil if it's not got mechanical protection in some sort of containment. But the short answer to the question, can I have a single insulated protected conductor outside of containment, is yes, you can.
Yeah.
And it's covered in that second sentence of the regulation.
It's a great point about the regs, in that, like you say, we often stop once we've got the bit of information that we think we need. We stop reading, don't we? And quite often,
every time,
it's important to read the whole regulation and to read the section that it's referring to. And yeah, that's a good example. And I guess it's all about the fact that our protective conductors should only really be carrying current for the time it takes the fault to clear. So if we've got everything else correct, we haven't got the same risks associated with a protective conductor as we would have with other live conductors that will be carrying current typically while the installation's in operation, and so therefore we need that extra layer of protection by putting them in containment of some form. Whereas when we're looking at protective conductors, that they'll only hopefully be carrying current for a short time till our protective device operates to clear the fault. So it's not the same sort of degree of risk that's seen.
No, we've still got to have some protection to it. I mean, there is a reg that talks about mechanical and chemical deterioration, electrodynamic effects. So there's other things that have got to be considered. You know, we've got to protect these protective conductors through their installation method and what they're exposed to, but it doesn't necessarily have to be in containment.
No, that's a good point, that there is that reg that talks about, you know, if it's required, it will have to have mechanical protection. So maybe based on if it was in a harsh environment where you've got, you know, lots of moving parts, etc., you might want to provide it with additional protection to ensure that it does work to achieve ADS or whatever its purpose is there for. So yeah, there is a regulation that tells us we do still, like with every wiring system, we do need to consider the environment it's installed in, and under certain circumstances it will need the additional protection of containment, but it's not a blanket requirement as it is for other single insulated conductors. Okay, we'll start to have a look at some of the questions that are coming through in the chat. So one that jumps up straight away is if a client requests a fuse board upgrade but we don't have earth to lighting circuits and do not want a rewire, are there any options to get around this and be able to complete a certificate? And I think one of the colleagues, one of the other engineers in the chat, has answered it. So one option that you can do, if a rewire is not an option, and also it's not an option to obtain an earth from another local circuit, for example, then you could consider using class 2 equipment. So look at all of the switches, all of the accessible light fittings, and make sure that they're class 2. So you're then going to rely on that element of protection for your protection against electric shock, and then we'd suggest a note at the board to inform people that there is no circuit protective conductor in that lighting circuit, and therefore then not to change the class 2 fittings for class 1 items, and then that would be acceptable to mitigate the potential risk and still allow you to do the consumer unit or fuse board change without having to add an additional circuit protective conductor into that lighting circuit. Would you add anything to that, Craig?
Only to say that there's a fantastic document, Best Practice Guide 1, free download from Electrical Safety First, covers that scenario fully. Yeah, fuse board change where there's circuits, lighting circuits, pre-1966, I believe, where there's no CPC. It covers it off and it tells you what you've got to do. It covers the points that you made there, Sam, with class 2 accessories, a label at the board. Fantastic document. Yeah. And it's free.
Yeah, no, very good point. Really good point. Another question that's come in. is that, hi gents, would an AC type RCD now be classified as a C2 under new regulations? So this is one of those ones that's it's a short question, but there's a lot of answers depending upon some of the other considerations that we'd have to have a look at. The first one I think would be is that we'd only consider an AC type RCD to be an issue in a circuit that we know has got a load or equipment generating DC current, which could be superimposed on the AC signal and could effectively blind the RCD. So if we know that we've got a circuit, a load and equipment that don't generate DC current, then there'd be no issue with using a type AC RCD for either additional or fault protection. And that would be the second thing that I think we'd always have to consider, in that most of the time RCDs are there for additional protection. So they're there for when we've got cables buried in walls, when we've got socket outlets, when we've got installations within a more hazardous environment or a special location. So the RCD provides additional protection, but there will generally be an overcurrent protective device providing fault protection. And generally in those situations, providing we've got adequate fault protection, then the lack of RCD providing additional only protection would only be seen as a C3 in an existing installation. Obviously very different if the RCD is there for fault protection, for example in a TT, because then we would suggest a C2 for lack of adequate RCD protection where it's required for fault. So two things I think you've got to look at as to decide on an existing installation whether it would be a C2 or a C3. First of all, determine whether or not the installation, the load or other equipment on the circuit can generate DC current, because that will tell you whether an AC RCD will function correctly or not. And then secondly, you've got to decide whether the RCD is there for fault protection, in which case if it's not adequate we'd recommend a C2. However, if there is adequate fault protection and the RCD is there for additional protection only, then if there was inadequate additional protection, in general we'd only recommend a C3 for its absence. Would you agree with that one, Craig?
Yeah, I think so. I think if you've got a piece of equipment that you know is going to generate DC component, then that's a different issue to whether you just suspect it. I think if there's no evidence for it, it would be very harsh to put it down as a C2. It's funny that I don't know if it's the bloke because I can't see the questions, but I've answered this twice today, to be honest, on emails. And I pointed them to electrical safety first again, on their frequently asked questions, and they have got a question in there that covers it. It says if it's identified and confirmed that the RCD does not operate correctly when tested, a classification code, I'll say it in a minute, C2 would be appropriate.
Yeah, no, I think
but if it's just suspected, then I think it'd be quite harsh to put a C2 against it.
Yeah, I think it's kind of in this transition, isn't it, as we're going away from general type RCDs to specific RCDs based on the application, that there's going to be these questions raised, because if we go back probably 5 years, then the only type of RCDs being installed were AC. So there's going to be a lot of installations with AC type RCDs in place, and people will now be reviewing those on their periodic assessment, or perhaps as part of additions and alterations, and then have to make the decision: are those type ACs adequate for the installation and its purpose? But yeah, it's not a carte blanche. No, they have to be removed and be replaced. It does depend on what the installation's doing, and is there any existence of DC current within the installation.
I think it's straightforward. If you've got a piece of kit that the manufacturers have specified it needs a particular type of RCD. Electric vehicle charger, for instance, is the obvious one. And you can say straight away, well, you've not followed manufacturer's instructions. And obviously manufacturer's instructions, you would assume that they've specified a particular type for a safety reason.
Yeah, and we see that more and more now on manufacturer's instructions, including, you know, white kitchen goods on boilers. So it's the manufacturers are becoming more and more aware, and then including those that information in their installation instructions. So yeah, it's worth again looking and sort of doing a mini survey of what's actually on site, what's being supplied, and is there a potential for DC current to be imposed in the installation. There's another one which again is a common question. So recently installed a fused spur to an existing ring for an outbuilding light, but unsure how to show on the certificate both the 32 amp RCBO and the 5 amp fuse. So this is one of those ones where so we've got our 32 amp overcurrent protective device at the origin of the ring circuit, but then within the fused spur we've got the 5 amp fuse, and we can rely on that 5 amp fuse for fault protection of everything downstream of the fused spur. But how do we do that when it's all on one line on a test sheet? And my advice always is that there's nothing hard and fast on this. I've seen it done different ways, but the method that we would suggest is actually show it as 2 lines. So effectively you've got circuit, for example, circuit 3, which will be your ring circuit with your 32 amp overcurrent protective device at the origin of the ring, but then circuit 3A is the circuit which is downstream of the 5 amp fused spur, and then that way you can differentiate between what's relying on the 32 amp overcurrent protective device and which parts and what cable are relying on the 5 amp fuse. So that's one way that I've seen it done, and that kind of makes sense and is easy to follow. Have you seen it done any other way or better way, Craig?
Well, I haven't, to be honest. That would have been my suggestion. People often fall into the trap. They think that these test sheets and these certificates have got to be filled out a certain way, and they haven't. They're not suitable for every type of installation, and sometimes you have to adapt and change things to make. As long as you get the information in there and it's nice and clear, there's no set rules about, you know, you've got to do it this way or you've got to do it that way. It's all about getting the information in there. So yeah, putting an extra line on there to clarify, well, this section is relying on the protective device at the origin, whereas this section is protecting on one further within the circuit. That's perfectly acceptable.
Yeah.
But people just think, oh, I can't do that because that's not another circuit in the board. Well, it doesn't make a difference, to be honest, as long as you clearly define what it is in your circuit description, etc. That's perfectly fine. Yeah,
I think that's right. It's getting all the important information down, which is more important as to how or why. Or so yeah, even if you did it on an extra sheet, you know, an additional sheet that's attached, if you didn't want to disturb the layout, because I know some people get very hung up on the order of circuits on the test page must match completely the layout in the consumer unit or distribution board itself. But yeah, as you say, there's, you know, they are just templates, and we should be using them the best way that we can, or adding them or altering them to ensure that we you know, it contains all of the right information. We've had a few questions come in about Amendment 2, and we'll leave those till the end because we've got a bit of news to tell you about something that's coming up in the very near future about Amendment 2. So if I can try and
Amendment 3, is it?
Say that again? Oh, it's not. No, it's not. It's not Amendment 3. We'd start a riot, wouldn't we, if it was less than a month into Amendment 2? No, it's not Amendment 3. So yeah, we've got a planned event for some of the Q&As that we've had already about Amendment 2. So let's just see if we can pick some of the other questions out that are other than Amendment 2. Hi, if testing and certifying to Amendment 1, do we make note of the 1 times tripping as you've discussed with Amendment 2, or do we continue to note the 5 times trip for additional protection as previously done? Many thanks. So yes, it's you've really got this 6-month period now where we could be designing and installing to either 18th edition Amendment 1 or 18th edition Amendment 2, and you should then be using the test certificate that's appropriate and the format. So if you are still using Amendment or designing and installing to Amendment 1, which you're more likely to be doing currently, then Amendment 1 would still talk about the 5 times test. And so if the RCD was being used for additional protection and you were working to Amendment 1, then yes, we would suggest following the requirements of Amendment 1, which would be recording the 5 times value. That's all changed now, as we're aware, in Amendment 2, where it's just a requirement to confirm RCD operation at I delta N, so whatever the nominal rating of the RCD is, and it should trip within the time required, depending upon whether it's a non-delayed or a delayed RCD. But that is then for Amendment 2. So although you might say it's the same type of installation, we're doing things exactly the same, why the two differences? Well, it's just to comply with whichever version of the regs that you've agreed to design and install to. That's the version that you should be testing and inspecting to as well. So don't make that change until you get into the scenario where you are designing and installing to Amendment 2. Then you should be testing and inspecting to Amendment 2 as well.
I think that's a great point, Sam, to be honest, that you've got to go Amendment 1 or you've got to go Amendment 2. You can't chop and change and take the best bits out of whichever one you want. Yeah? So if you're doing it to Amendment 1, you've got to do everything that we did to Amendment 1. When we move over completely and we go fully Amendment 2. Yeah?
Yeah, because it's all part of your declaration, isn't it? You'll be signing on that certificate, whichever version you're working to make it clear which version you're working to, and then you need to complete the inspection, testing and certification in line with the version that you're working to, and there will be differences. So yeah, I can see that there will be some advantages in terms of time required, the amount of testing and the amount of certification if you go into Amendment 2, but remember then there will be some other requirements. There will be changes then in terms of your design and your installation requirements too. So yeah, you've got to do it all to the same version, and by all I mean design, install, test and inspect and certificate have all got to be to the same version. Let's have a look at what else have we got coming in. Does the plastic consumer unit issue apply to a meter tail isolator with a type 2 RCD in it? No. If you look at the regulation for non-combustible consumer units or plastic consumer units in a non-combustible enclosure, it does talk about consumer units or similar switchgear, and it gives a British standard to which those type of equipment or assemblies should be manufactured, and they won't include your meter tail isolators, for example, or switch fuse isolators, and it's just seen that it's a difference of type of assembly and also connections, so the same risk isn't seen as being there for an isolator which once connected will be very likely to be changed, whereas within a consumer unit you've got the option for additions and alterations throughout the life cycle of the installation. So you've got an increased risk, for example, of loose connections and issues around the consumer unit and the equipment within the consumer unit that increase the potential for heat and combustion and fire. So it's seen very differently in terms of risk, and that's why things like isolators, switch fuse isolators, aren't seen as having the same perceived risk, and therefore don't need to be of a non-combustible material. So no, it's not seen as the same. Doesn't fall into that regulation. Doesn't fall into the similar switchgear. Doesn't fall into the British standard, which is associated with consumer units and distribution boards. What else have we got? I would like to know too, but I haven't said what any other parts. So I'm just reading through people answering each other, which is all good to hear and see people helping each other out. We've got a reg. There's a note again. I think this is an amendment 2 that devices conforming to BS 7288. So those are our RCD spurs and our RCD socket outlets. Only provide additional protection. Correct me if I'm wrong, but doesn't the standard itself say that this is suitable for supplementary protection and that additional protection should be provided upstream? I've seen manufacturer instructions that say it too. I think this is around the issue that in the 18th edition back in 2018 they published that, and within that document there were a couple of lists which talked about RCD types that could be used in installations that had skilled people, and RCD types that could be used in installations that were non-skilled people. And from both those lists, BS 7288 devices were omitted. But we said at the time and firmly believed, and I think we've been it's been proven that was an editorial issue. It wasn't a deliberate thing about the differences, and so you'll see now in 7671 Amendment 2 2022 that those devices are back in and can be used to provide additional protection for downstream of those devices. So yeah, you may still need for example an overcurrent protective device upstream, but you can rely on the RCD within those devices to provide additional protection from the circuit downstream of those devices. That's just about that story behind that change, isn't it, Craig?
Yeah, from what I can remember, that whoever's wrote in, he's obviously he knows his stuff, because I think it did say in 7288 that they needed additional protection upstream, which sort of nullified the use of them, because if you've got additional protection upstream, there's not a lot of point of having an RCD spur or an RCD socket downstream if you've already got the protective measure there. And I think what happened was that the committees involved asked for a special national condition, or a some countries note as people call it, to get the 7288 RCDs reinstated into 7671, which was what happened recently. So they're back in there, so we can use them only for additional protection and only for additional protection downstream. But there is a special national condition that sort of takes away the requirement of 7288 in the fact that you need additional protection upstream. Yeah, that's only for the UK and Ireland, I believe.
Yeah, and we should say that, you know, that special national condition, that's why we have our UK reg numbers, that you know, the 201s and 101s ending in. So that's what the things then where we differ slightly in some form or another from our European counterpart. So it's not a true BSEN, it is a British standard because of those changes, but based on the same European standard. last question, because again we're running out of time tremendously. Does an SWA cable buried in the garden to an outbuilding require RCD protection? So a couple of things. If we're talking about a TT installation, it may well need RCD protection, because in a TT installation with the high resistance associated with the earth electrode, we're probably not going to meet the disconnection time requirements for a breaker or a fuse. So if it's on a TT installation, it more than likely will need RCD protection. If it's a non-TT, and I think, sorry, as the engineer come back in again and says, replying to Andy James, it depends on earthing system. So someone else has said, if it's not a TT installation, so we don't need an RCD to provide fault protection, it is just for additional protection, then generally if we earth the armour in, then that it won't need RCD protection. So depending upon if we're burying it in the wall, for example, then whereas with as long as we earth the armour in, it wouldn't need RCD protection, because it's one of those wiring system types that's got earthed mechanical protection. So in answer to the question, does depend very much on the earthing arrangement, and does depend on the use, but in general for a non-TT, providing we earth the armour in, then it shouldn't require RCD protection unless for example it's being used to supply socket outlets on a farm, and then the circuit will need RCD protection. So again, you've got to think about, is it a special location, what's it being used for, but in general the cable itself, as long as we earth the armour in, and it's not a TT installation, won't need the additional protection of an RCD. But you do have to think about what am I supplying, because that might need RCD protection, and what type of location am I in, because there may be some enhanced protective requirements. Okay, we'll finish off tonight with another question that's common on the helpline, because there's a few regs that talk about this. Is it a requirement to periodically inspect and test electrical installations? So Craig, what does BS 7671 and what do other standards tell us about? Do we need to periodically inspect and test electrical installations?
Well, can you say the question again, Sam?
So is it a requirement to periodically inspect and test electrical installations?
It's not a requirement. Yeah, there's no requirement in 7671 that says you have to do it. Yeah, it's recommended. This is a big difference between a requirement and a recommendation. So there is a reg that says it's recommended every electrical installation is subjected to periodic inspection and test in accordance with chapter 65. Yeah. Obviously there's other regs in there that says in chapter 65 that says if you've got a maintenance routine, yeah, preventative maintenance that's documented, yeah, then that could take the place of a periodic inspection. So you might inspect and test different parts of the installation as part of a maintenance program, which means that you don't ever have to do a full periodic inspection and test. It might be a better system for larger, more complex installations. So it has to be subject to some sort of inspection, yeah, not necessarily a full periodic inspection, yeah. And that all stems from electricity at work regulations, yeah. So we've got to, where necessary, we've got to prevent danger, yeah, and we've got to maintain systems, yeah, to prevent danger. So it all stems from the electricity at work regs, which then cascades down as to, well, how do we do that? And it all depends on the nature of the installation, yeah. Simple domestic installation is not a problem really, you know. PRS legislation coming in every 5 years as a maximum, we've got to get it inspected and tested, yeah, to prove that it's safe for continued use. On different types of installations, you might have a different regime in place, yeah. You should still carry out the maintenance, but not necessarily as we would on a normal, everyday periodic inspection.
Yeah, and it's. I think 7671 recognises, doesn't it, that it's not suitable, like you said, for all installations. I mean, I come from an automation background where, you know, 24-hour, 365 days a year operation was required. So you doubled up on things and took one out at a time and did the preventative maintenance to ensure that when it was required, it would run efficiently and safely. So there are other mechanisms you can use to check for safety for continued use. Periodic inspection is just one of those. There are other things that you can do, and I think that's recognised in 7671. So a lot of people take, you know, they get quite bent out of shape when they see that reg right back in our fundamental principles that says it's only recommended, it's not a requirement, and it's because it doesn't suit all types of installations. But as you said, the overarching regulation is electricity at work regs, and as we all know, that's statutory, so that's a legal requirement that you have to have something in place to prevent danger and to make sure that all systems are maintained to prevent, as far as reasonably practical, such danger. So that's the one that tells us you've got to be doing something, and 7671 then makes it clear, well, we recommend periodic inspection, but it's not a requirement because it's not applicable or suitable to all types of installations. So that's why it doesn't enforce it. It's not a regulatory requirement for that reason, because it's, you know, if we had to shut down installations to do a thorough periodic inspection, it would mean that, you know, commercially they're not viable, and so it would never run. So we have to have other means, such as preventative maintenance, that make sure that things run safely.
It could also create a danger, couldn't it, if you shut a certain process down? You know, some things have to be monitored and continue to run.
Yeah.
You know, and you have to plan it accordingly.
Yeah, I mean, it's all over the news at the moment about the nuclear power station and what some poor people have had to do to try and keep that running, because that, you know, that's a classic example. You can't just turn that off at a flick of a switch. That, you know, there's a very hazardous process going on there, so it has to be started and shut down to a specific series and pattern and regulation, and so it's got to be done properly, and it's not just a case of switching something off immediately. Okay, we've run out of time again. I just want to make viewers aware that one of the reasons why we bypassed some of the Amendment 2 questions is that we've got a specific Amendment 2 Q&A panel coming up. For those people that didn't know, we ran a series of events a couple of weeks ago, the week when Amendment 2 was launched, beginning the 28th of March. We had 30 events up and down the country, and we also did a couple of live webinars on the Monday and the Wednesday, and on the back of that we got asked some questions, most of which we covered on the night, but some that we held over because we were just we had lots of events and we're inundated with questions at each of those events. So we've pulled all of those questions together, and we've now got the NIC team that helped with the panels that put together Amendment 2. So the NIC representatives on each of the panels are going to appear on, it's Thursday the 28th, so that date's been chosen so that it's exactly 1 month after Amendment 2 was published. And we'll be going through the questions and answers, so that won't be so much an Amendment 2 presentation as an Amendment 2 Q&A session, and that event is open and up on our website now, so you can register for it. And as part of the registration process, if you've got a specific Amendment 2 question, you can post that to us as well, and we'll hopefully get round to answering that on the night. So that will be 8 o'clock on Thursday the 28th of April, and we'll be doing a Q&A session for the night, picking the most frequently asked questions around Amendment 2. So please, as I say, go to the website and you can register for that event now. Other than that, thank you very much for everybody that's contributed tonight and putting the questions in. I do apologise if we didn't get round to your question. That might be because we're holding it off until the 28th if it was an Amendment 2 specific question. If not, then we will get round to it. We'll use it to start off another one of these Monday night sessions. Anything else you'd like to add, Craig?
Yeah, I think it's been a good session, some good questions coming in, and hopefully they keep coming in for the Amendment 2 presentation or question and answer.
Yeah, no, that's really good. So from Craig and myself, thanks very much. Thanks for your questions. Apologise if we didn't get round to answering yours. We will get back to you. And please, if you're interested and have got some Amendment 2 specific questions, then get those down. Register for the event at the end of the month, and hopefully we'll get on to your question too. So I'll leave you with that advert popped up so that you can see that, and look forward to seeing you on Thursday the 28th. Thanks very much.